Hi gents, we're going to now have a little look at just different topics. We'll just do one a day here, where we go back and have a quick little look over major topics, just a quick revision class for you before we head into the exams. What I'm going to try to do, I don't promise that this is going to work perfectly because I've had a few issues with it. At least I can draw on the page. What we'll do is we'll just use study clicks here, just to have a little look at trigonometry, for instance. Okay, so again, just rather than me remind you, you should try these just before I do them. Okay, we've got a right angle triangle. We have to find the value of x. We know that this angle is 20, so we're going to work off 20, and we're just going to say what each side is. So the side which is opposite 20 is called the opposite, unsurprisingly. This is the hypotenuse, it's opposite the right angle, and that leaves us with the adjacent here. So the ones that we know the opposite, and we want to know the adjacent. Opposite and adjacent, which of our three trigonometric functions? Hopefully you remember it's tan. Tan of an angle is equal to the opposite over the adjacent. So in this case, it's tan 20 is equal to opposite, which is 6, over adjacent, which is x. This is why algebra is so important, why I spend so much time on it. Knowing what to do here is important. You don't want x on the bottom, so what do you multiply both sides by? Multiply both sides by x. This side, x tan 20. And on this side, if you want to do it like really slowly, this side also by x, just to show what you would get. When you're multiplying by x, you're multiplying x over 1. This thing would be, just to show you, it would be 6x over x. X divides in to leave 6. So that's why, I mean, you don't have to write that bit in. You can say I'm multiplying both sides by x. Left hand side, x tan 20. Right hand side then just leaves you with 6, which was the whole point. And now, to get x on its own, tan 20 is just a number. So, if you had 5x is equal to something, you'd multiply, or you'd divide both sides by 5. In this case, x is being multiplied by tan 20. So you want to divide both sides by tan 20, just like you would have divided by 5. Tan 20. So we get x is equal to 6 over tan 20, which is perfect. Okay, so let's go and do that. 6 over tan 20. Make sure you're in degrees mode. That's important. There are other modes on your calculator. So make sure it says D. And it says that x is equal to, now they wanted 2 decimal places, so this is 16.484, so 16.48. Did they say centimeters or anything? They didn't. So there we go. That's it. Okay, that's it's a good one to try out, just to remember. Do you know your very basic, and that is basic, sine, cos, and tan? Okay, we'll have a look at this. A different right angle triangle is shown. It has sides length A, B, and C. One of the angles is Y. Okay, in this triangle, A plus B, A and B added together are greater than C. Okay, well, we know that that has to be the case. Okay, can you think why, actually, just before I do it? What's the argument that A plus B has to be greater than C? And it's just to do with the distance between 2 points. If we take these 2 points, the fastest way there is directly along C, is directly there. Of course, if you go that distance and add on that distance, it's going to be longer or bigger than just going to C. So that's why A plus B has to be bigger than C. It follows. Now this question, I imagine that this was quite tough for third years, because use this point to prove that this is true, and all of a sudden you're thinking, ooh, this is tougher. But look, whenever you get a question like this, just don't panic. Okay, what is it saying? It's saying cos y plus sine y. Well, let's get what cos y is. That should be your first instinct. And cos is adjacent. Well, yeah, we have to be careful how we write it, because A is in use. Adjacent over hypotenuse. Okay, the adjacent is, in this case, it is actually A over the hypotenuse, and the hypotenuse is C. Okay, and we should, I suppose, get what sine y is. Like, it's not even clear to me at the beginning, oh, how is this going to work out? But you have to be willing to take some steps to find out. So that sine is the opposite over the hypotenuse. Opposite is b, and the hypotenuse is still c. So if we take this line here, we have that cos y plus sine y is greater than 1. What we can now say is we can say that that's the same as saying that a over c plus b over c is greater than 1. Okay, why? Because cos y we just got was a over c, sine y was b over c, and now we have this particular inequality. What can you multiply everything by? And remember, c is a positive number, so you don't have to worry about multiplying everything by it. It won't change the direction of the inequality. Everything by c, we just get a plus b is greater than c. So there you go. So it turns out that if that bit is true, then you can work back to that. Okay, why? Because we started with this line here, and we were able to create that line, and we were able to create that line, all by logical steps, and we know that this one is true, so you could just reverse those steps and it would bring you back there. So that's literally all that you would have to answer. So that one was sort of scarier, I guess, than what it seemed. I wonder, in fact, can we even get it to interact? I'm not so sure. We'll just say no to this, and we'll have another go at some stuff. Okay. Okay, that's more about congruency more than anything else, really. Let me see. No, it's perimeter. It's just adding together some of those things. So let me see if I can find a tough actual trigonometry one. Okay, well here's trigonometry one straight away. So question 11. Let's see, does this work? I guarantee it. Yeah. Okay. So it says f is a right angle triangle. Is an angle in a right angle triangle, and f is equal to cos of f is equal to 6 over 11. By drawing a diagram of a right angle triangle, find the sine of f. Okay, one incorrect thing to do here, let me just tell you, one incorrect thing to do, which is really tempting, because it will get you pretty much the right answer, is to find out what f is by doing cos inverse of 6 over 11. Okay, you can find out what that is, so f will be some number of degrees, and then you just do sine of that some number of degrees, and there you have it. Okay, that's not how they want you to do it though. There's a much classier way to do it, and it is, as they say, they actually give you the hint here, it's by drawing a right angle triangle. Okay, does not have to be to scale. This is the great part about it. Does not matter. Just draw f in as one of the sides, or one of the angles. It can't be the right angle, obviously, because it says f is in a right angle triangle, not it is the right angle in a right angle, the right angle in a right angle triangle. Now, what does it say? It says the cos of f. Now, what does that stand for? That is the adjacent over the hypotenuse. So this is the opposite, this is the adjacent, and this is the hypotenuse. So the adjacent we know is 6, because it is meant to be adjacent, and the hypotenuse is 11. So it's in that ratio. And what are we asked to get? We're asked to get what is the sine of f. And the sine of f is the opposite for the hypotenuse. Well, we know what the hypotenuse is, it's still 11, but we don't know what the opposite is. And the way to get this, can you figure it out? Just pause me before you do it. It's of course using Pythagoras' theorem. X squared plus 6 squared is equal to 11 squared. You're just using your a squared plus b squared equals c squared. So x squared plus 36 equals 1, 2, 1. So if we subtract 36 from both sides, we get x squared is equal to 85. We can now say that x is equal to the square root of 85. So root 85 And that's the opposite. X was the opposite. So we can now answer a question, what's sine f? It's equal to opposite over the hypotenuse. Well, the opposite is root 85, and the hypotenuse is 11. That's a very nice one. I really like that question. It's an important one to be able to do. So I would say, yeah, big thumbs up on being able to do that one. Save your changes. No. So let's try this again. I played around with this website and trying to do it like this. It's not easy, I'm going to be honest with you, but I think it's worthwhile. Yeah, I think this is a big one that I'm interested in, and I want you to spend some time on it. Yeah, this one here. 2017 Note Out, Paper 2, Question 12. So you may have a copy of it there in front of you. The diagram on the right shows a right angle triangle with a hypotenuse of 10. Use trigonometry to find the length of the side x. Give your answer in surd form. So this one, I actually want you to really take this as homework, but I'm going to give you the answers now. So you do your homework and then you come back and you just watch the end of this thing here. Okay, let's get x here. X is the opposite. 10 is the hypotenuse. So opposite and hypotenuse, we're dealing with sine. So sine 60 is equal to opposite over hypotenuse. That is x over 10. And this one's not as bad as the one that we started with, because in order to get x on its own, you just have to multiply both sides by 10. So 10 sine 60 is all you need to type in into your calculator. So 10 sine 60 is 5 root 3s. Okay, were they centimeters or anything? No, just said units. Okay, that I hope that you were able to do nice and easy, but this bit, you're going to have to come up with a plan. The diagram below, and it's very much related to the one above it. Okay, the diagram below shows a regular hexagon with sides of length 10 units, just like the one above. The hexagon is divided into 6 equilateral triangles. Okay, 6 equilateral triangles. Work out the area of the hexagon, the whole thing. Okay, so first little nudge, and if you weren't able to do this before, pause me the second I give you this nudge. What you should be thinking of is, if I draw a line down here, I'm going to create that triangle that I had above, and in fact I'm going to, of course, just double it there. Okay, so have a go at it now if that helped. I'll just keep putting in our answers. In fact, if we were to do this the whole way along, what we'd see actually is that we've got, and look, there's more than one way to do it as well. I could also have, well, actually, no, I wouldn't want to do that. So hold on, let me do this correctly. 10. It's just actually a little bit easier to see this way, not the other way was wrong. So this is 1, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, and of course there's going to be 12 of them in total that's going to be repeated. And also, when you think about it, what we're doing is we're taking a hexagon, okay, which has 6 equilateral triangles, dividing each one in 2. So of course there's going to be 12 of them. So if you can just find out what is the area, what's the area of the triangle? That's 60, that's 10, and we just got 5 root 3 there, so we know a bit about this. If you can get the area of one of these things, all you have to do is multiply it by 12, because there are 12 of them in the whole hexagon. So here's what we need. Area of a triangle is half the base times the perpendicular height. Okay, half the base times the perpendicular height. Perpendicular means right angled height, and there you can see that we already have the right angled height, so it's just a question of what's down here. What is the base? Well, of course, you know, since it's equilateral and since you've divided it straight down the middle, equilateral means that they're all the same length, so that will be 10, so we know that it's going to be 5, but let's say that you didn't. We'll call this thing P here. What we'll say is it's the adjacent, which it is, so you could say cos of 60 is equal to adjacent P over the hypotenuse 10, and P would equal to 10 cos 60. That'll be just a good double check, and it turns out that P will be 5. Okay, so we get that the area of one triangle is equal to half the base, half of 5, times the perpendicular height, which is 5 root 3. So that is going to be AT is equal to 25 root 3 over 2. How do I know that? It's over 1 and it's over 1. Top by top by top, bottom by bottom by bottom. And remember, what we want to do now is the area of the hexagon is 12 times the area of the triangles. So we're going to do 12 amounts of 25 root 3 over 2. So that is going to be 2 divides into 12 to leave 6, 25 root 3. So I'm just trying to do this in my head as opposed to anything. So that is 150 root 3s, and you do need to put in units squared because we're getting area at the end. And look what it asked. It said show that, or give the answer in the form some number of root 3s, where some number is a positive whole number. And that is what we've ended up getting. A really good question there on trigonometry. Hopefully you found that useful. Okay, gents, thanks a million. All the best.